Hi, welcome to another set of video notes. Now you notice I'm dressed very festive because I'm doing this before Christmas break is over, just like you might want to take your video notes before Christmas break is over, if you don't want to get a bad grade. So we are moving on to 3.5. We are going to start doing some things you've never looked at before, never worked with, and it's called basic matrix operations. Maybe you've seen the movie Matrix. That has really nothing to do with what we're going to do. So first of all, a matrix is like a box, and it will have numbers in it. And they can be positive, they can be fractions. Let's change this, let's make it a fraction. And it's a way of organizing some information, okay? The one thing I want you to know here, and this is something you might want to put on your study card, is that rows are this way, and columns are this way, okay? And just like columns at a house go straight up and down, that's what columns here. So a lot of times teachers will say, pass this down the row. It's not really a row, they're passing it down the column. Okay, but don't correct them, they won't like that. And you talk about a matrix size or dimensions. And when you do that, you list the number of rows first and then the number of columns. So this would be a 2 by 3, okay? To be able to add or subtract matrices, they have to be what we call equal, or in other words, they have to have the same dimensions. If they don't have the same dimensions, you cannot do it. And you write, Mrs. Roth, can't do this problem. What were you thinking? Okay? So, something easy like this. This is, what are the dimensions here? Let's see, 2 rows, 2 columns. So this is a 2 by 2. What is here? 2 rows, 2 columns. They're exactly the same, so we can add them. Now this is the part you are going to love. This is so not stressful. When you add matrices, my phrase to you, sorry Nike, is just do it. What do you think you'd add the 3 to? Oh, the one that's right here. Yep. And you get 3 plus -1, or... what is this, a 2 by 2? We can run into this. 2. We say -5 plus 2. And what does that give us? -3. What are you going to add the 0 to? 4. Very good. 0 plus 4, it's a 4. What are you going to add the -1 to? Oh, the 0. And you get -1. And this is your answer. Okay? They're not going to get any harder than that. They might be different size. Let's see, how many rows does this one have? Well, this is a 3, and it's got 2 columns. This has 1, 2, 3 rows, and it also has 2 columns. And I'll tell you now, if you can learn to write them about the same size, it'll make things easier. Notice this time we have a minus inside, or in between the matrices, but we're just going to subtract. So what are we going to subtract from the 7? 7 minus a -2. And here, I'll just come over here like this. That gives you 9. 4 minus 5. Well, that's just a -1. 0 minus 3. That's just a -3. Is this too much? -2. What are we going to match up with that? Oh yeah, this one. -2 minus a -10. Oh, that's not bad. That's just 8. -1 minus a -3. I remember, I don't really like all these double signs. Just think of it as -1 plus 3, which is 2. And we've got 6 minus 1, which is 5. And that's your answer. You got it. Okay? Pretty easy? I hope so. Let's go on to scalar multiplication. Now, scalar multiplication means we've got a scalar, or in other words, a number in front of the matrix. Okay, so maybe you'd have something like this, 2, and then inside we'd have 3, 1, -1, 2, 0, and just for fun, we're going to do 1/3. Okay? Now, scalar multiplication. Does that remind you of anything? Oh, maybe when you had the number out in front and you distributed. That's exactly it. So 2 times 3 gives you 6. 2 times 1 gives you 2. 2 times negative 1 gives you negative 2. 2 times 2 gives you 4. 2 times 0, 0. And always, let's do the fraction. 2 times 1/3, oh, 2/3. Okay? You just distribute. Not a big deal. Here are some properties of matrices. These things are all true. Matrices, okay? Associative. If you've got 3 in a row, doesn't matter whether you add the first 2 or the last 2 first. Just like real numbers, it's the same. Commutative, A plus B, you could add it as B plus A. It'll give you the same thing. Distributive property for addition, you got the number out in front. Distributed, that's your scalar. You might note that that's scalar, and that's just a fancy word for a number, a scale factor. And then you've got distributive property of subtraction, same thing, okay? So hopefully this isn't stressing you out, all right? We've got one more thing we can do with this, and this is really, those problems are fun. This is really why we need to know how to use matrices, because you can use them to solve systems of equations, okay? Remember last semester we did graphing lines, we did substitution, we did elimination. Now we're going to look at matrices. Okay, now sometimes we have a matrix equation, and you notice there's an equal sign there. That's how you know it's an equation. Let's remind ourselves, what does it mean when you have a number out in front? Oh yeah, you distribute. So negative 2 times negative 3x, negative 6x. Negative 2 times negative 1, negative 2. Negative 2 times 4, 8. Negative 2 times y, negative 2y. So notice when you multiply by a scalar, it doesn't change your size. All right, well, we also need to distribute this negative 2 to this matrix. So negative 2 times 9, negative 18. Negative 2 times negative 4, did you catch it? I hope so. It's a positive 8. Negative 2 times negative 5, positive 10. Negative 2 times 3 is negative 6. Okay? And now should we distribute this all the way over here? No, Mrs. Roth, because it's not in the parentheses anymore. So we just have 12, 10, 2, and negative 18. Okay? So the last thing to do is, let's see, we want to solve an equation. We want to find our x. So x is right here. We have negative 6x. Would we add anything to that? Oh yeah, negative 18. So plus the negative, or just minus 18. And then we have it equal to what's in the same spot? 12. Okay, so you can just solve this. Let's see. Add 18 to both sides. And you get negative 6x equals 30. Oh, you know what, though? Negative times a negative is a positive. Delete. So 6x equals 30. Divide each side by 6, and you get x equals 5. Okay? Are we done? Nope, because we've got a y. Let's find the y. It's down here, and that's negative 2y. What's in the same spot in the next matrix? Oh, a 6, so we get minus 6. And what's in the same spot over here? Oh, negative 18. Okay? So let's see. We're going to add 6 to both sides. We get negative 2y equals negative 12. We divide by negative 2, and you get y equals 6. So you just solve this. It's 5, 6. Okay? And this is just getting us used to doing some of those systems. All right, so we'll be practicing this in class, and I hope your break is great. Bye.